11. The three masses shown in the accompanying diagram are equal. The pulleys are small, the string is lightweight, and friction is negligible. Assuming the system is in equilibrium, what's the ratio of A over B? So we have to find the distance ratio of this length over that length. And we are given equilibrium position. I'm gonna first draw the force body diagram. I have tension on each of our mass, and these tensions are equal to each other because they are all connected by the pulleys, and we have the mass of we have a force due to gravity, and from looking at this we know that T equals mg, and we'll use that later. For now, I would like to discuss the equilibrium here. When the system is undergoing equilibrium, the net torque has to be 0, as well as the force net in y and x direction also have to be 0. I'm gonna exploit the middle mass so that I can find the length relationship between this left lever arm and the right lever arm. For now, I'm gonna call the left lever arm length to be x and the right length to be the a minus x. So when I draw the torque diagram using this middle mass, I have lever arm length x and a minus x, and then there is the force due to gravity pushing it downward. They happen to be same, so I have mg and mg here. Now if you take a look, it's gonna go, the one on the left is gonna go counterclockwise, so by convention you get the plus sign in the torque equation, and then this gets the negative. The right side, the right lever arm is undergoing the clockwise motion, so I have to have negative sign in front. So when I write that, I have to have mgx, that has to be positive, and then minus mg a minus x. Now I can distribute one on the right side. And then push the second term to the left side where you see the 0. So you have mga equal 2mgx, and notice how mg cancel out on both sides. So I have a equals 2x. Ultimately I get x equals a over 2. So what that tells us is that the left lever arm and the right lever arm have the same length. So we have a over 2 here and a over 2 here. Ultimately we get the symmetric, or rather the identical triangle formed if we draw a horizontal line along our second mass, the middle mass here. So I'm gonna draw that to illustrate my point. Because we are interested in the lengths A and B, I'm gonna draw this triangle. And now I would like to find the angle theta. Okay, let me erase that. Oops. Let me try it bigger. Okay, sorry about that. Okay, we have identical angle, and we also have the length, the horizontal length to be a over 2 and a over 2, and don't forget our force due to gravity is acting downward, and then we have a tension of the string on both sides of the triangle, and we just have to focus on the y net here. So I'm gonna write the so my goal now is to find that angle, and to do that I'm gonna add the 2ty. So if I call this to be t, the one on the opposite side has to be ty, and then we have two of them here. So 2ty will cancel out with the mg, two ty, you can say minus mg equals 0, and that ultimately becomes 2ty equals mg, and the ty can be calculated by using the trig function. So we have opposite angle here, so it will take the sine theta times the tension. So ty is t times sine theta. So you can plug that in to this part. So we get 2t sine theta equals mg. But earlier we declared t equals mg, as you see right here. So I can replace t with mg. Now I can cancel out the mg. So I have sine theta equals 1/2. And if you're comfortable with the unit circle, you will notice that angle theta is 30 degrees. If you are not, just use a calculator in degree mode. Okay, so I found the angle now, but ultimately I want to find the length ratio of the horizontal length and the vertical length. So to do that, we just have to use the simple geometry. So let me draw just one part of triangle. 2 is kind of redundant, so let me draw that. Okay, I chose the right side, and it doesn't matter if you choose left side. However, the angle is 30 degrees, and we know the length, horizontal length, to be a over 2, and we do know the vertical length of our triangle has to be b from the given diagram. Okay, so now we just have to use a tangent or cotangent. I'm just more comfortable with tangent, so if I use a tangent 30 degrees, it's the opposite over adjacent, so it takes the b over a over 2, and when you simplify the right side of the equation, you get 2b over a, and that equals tangent 30 degrees. And tangent 30 degrees, if you remember trigonometry, trig, you get the so if I use a unit circle here, the vertical length becomes 1/2 and the horizontal length becomes radical 3 over 2. So when you divide the opposite over adjacent, you get 1/2 over radical 3 over 2, and you ultimately get 1 over radical 3. Okay, so I can replace the tangent 30 degrees with 1 over radical 3, and I have 2b over a, but we want to know a over b. So I'm gonna flip this, flip the fraction on both sides, and I get the a over 2b equals radical 3. And then if you just multiply by 2 on both sides, you get the answer. So the ultimately a over b is 2 times radical 3. Answer is E.